Hey, and welcome back to Gaming for Tokens. I'm Marshall, and in this episode we're going to be picking up where we left off in the last episode, which is to say I'll be talking about how more of my Breakout clone works and how you can manipulate the environment and how my catcher script works, because I don't think I talked about that. Hopefully this will be a shorter video than the others. I'm hoping to keep it around 20 minutes. We'll see. So that's hold me to it if it's not 20 minutes or under. Well, around 20 minutes. I don't know. Whatever. You get what I'm saying. The first thing I wanted to look at was how I am doing health and destructible objects in my game. So I have these bricks here, and I can destroy them, and they go away, and they give me points and all that jazz. I won't be covering the points in this video. That'll be the next video. The next video I'm going to be talking about how I took all these pieces and actually made it into a game, which I think will be very, very useful. It's the first time I've handled a system type script. Not like computer system, but like game system. And I'm going to try to not wander away from the mic as much as I did in the last video. I think I just did that. So let's dive right in. We're going to be looking at these guys here. You'll notice there's a lot of them. And they all have the same script attached, which is brick. So I should have that guy open here. Make that bigger for you guys. So they have a couple easy public variables on them. I'm going to be looking at the prefab over here for the script that I have. So I have brick 1 and brick 2, and the differences are the colors. So this is brick 1 and this is brick 2. You'll notice that there's a slight difference in the stats on them as well, but effectively they have a health, they have a visible mesh, they have a vismesh damage scaler is what that is. There we go, scale inc, which is increment. They have a destruct score and a hit score. So the things that these control, this is the health, this is an integer value that is the number of hits this object takes before it is destroyed. So in this particular case it's 1, in the other one it is 5. So I went with increments 1 and 5. The visible mesh on this is the housing, which is the center color block. You'll see that on these I basically have a red block and a solid color block. The red block is this red outline that you're seeing, because I know that I'm looking at it in orthographic view. So I made them look like this in 3D view. And then the other object under it is that red outline. Whoa, let's close this guy down. Wow. So yeah, I have a red cube, and I have my visible cube, my vismesh cube, as I'm calling it. I have viz housing and brick outline. Brick outline is just using a particles additive shader, which is probably not the best shader in the world to be using, but that's the one I'm using because it was quick and easy and built in. The other one's just using the default material, I believe. The actual brick object has the brick script and a box collider on it, and that's it. Nothing else. The box collider is, if we look at one of these guys, the box collider looks like that. So it's the same shape as the outline object. And yeah, the script itself, I can go over it here, I guess. Health is how many times it takes to hit. I already talked about that. I just showed you what the vismesh was. Vismesh damage scale increment is here. Is this the guy on the bottom right? It is. Okay, so watch what happens when I hit this object here with the ball. Oh, that's a bad example. Hang on. Let's look at this guy. Every time I hit him, that interior solid object shrinks down, and that's how I'm getting that increasing red outline down here, is by just scaling that guy down. That's what this does here. So the scale of the object decreases by 0.125% every time you hit. So in theory, because it's a percentage, it will never actually hit 0, which is a good thing, but it also will take, if you're looking at this as I think it will hit 0 eventually. It'll probably go negative eventually, which is not good. We can fix that in this video. But the primary thing here is that that's a small enough increment that if I multiply that by whatever 5 even down here, then it won't equal 1, right? Because that's going to be like half. So it'll scale down to just over half of its original scale, and then it'll go away. Yeah. So that's the scale increment. The next one is the destruction score. That's the amount of points we get for breaking the object. The next one is the hit score. That's the amount of points we get for hitting the object. You'll notice that I'm using both here. We might want to change something in our script that makes it so we only get the destruction score if we hit it and it breaks. I think currently you get both. You get a combination of. So right now you're getting 4 points for hitting this, I think. And in this one, you have the starting health, which is 5. So it takes 5 hits to get. They still have the same damage scale increment because I didn't feel like changing it. Because you don't see the damage scale increment on 1 anyway because it's 1 shot and it's down. But this one you do. So I really focused on tuning this value for this one, and then I made brick 1 out of brick 2 technically. Anyway, the destruction score on this guy is 12. So when you destroy him, you get 12 points. And every time you hit him, you get 1. So you'll see that represented here. When I hit it. 1, 1, 1, 1, 1, 12. Okay. So it looks like I'm not giving you the extra hit score. I think that's intentional. If that's the case, then I should get 3 from this guy and not 4. Yeah. So that was the way that I intended for it to be, and I think the other one was a bug that I was worried I might be getting. But I'm not, so that's good. So let's start looking at this script. It's pretty straightforward. Here's all of the variables we just went over. I have this breakout main. I'm going to talk about that in the next video. That's going to be my system script. I need to attach my brick. My brick needs to be attached to my system so that it can give me points, basically. And I have an int for current health. That's the amount of health that we currently have with the damage that we've taken so far. So on start, I'm going to set current health to be our starting health, which is up here. And this is that system script that I was talking about again. We're going to ignore that for now. Update does nothing. We can get rid of it. And the only function on this thing is the damage function. In the ball script, I said to kind of gloss over that, and I'd be talking about how that works a little bit later, and now is later. So when we hit our ball, so this is the ball script again, the same script I went over in the first video. When we hit something on our object hit script, we check to see if the tag is paddle or if it's ball, or if it's paddle or brick. That's the only things we're looking for, because that's all we really care about if the ball hits something. If it hit a paddle, remember we do all that fancy math with the spin vector and all that stuff. But if it's a brick, all we do is send message damage and then the variable or an integer 1. So we're going to deal 1 damage to the brick that we hit. I also print out a debug message saying that I hit it and what my reflection vector is and all that stuff. That's just for me. And then I instantiate my bounce effect. So all this stuff is pretty standard rote at this point. But this guy here, this is how I usually do damage in games. I find that it's a lot easier. It might not be the most efficient thing in the world, but I think it's so easy that I don't see why I wouldn't use it, even if it was a little less efficient than doing it some other way. So I think I've talked about send message in my other videos, but just to go over it one more time, just in case you haven't seen that video or whatever. Send message is basically you tell an object to call a function on all of its scripts called this, and then you can feed it 1 variable, which is I'm feeding it an integer of 1. So I'm saying, hey, hit object, the object that I hit, look through all of your scripts for a function called damage and set it and feed it a variable of integer 1. So what it's going to do is it's going to look through, it's going to find this script, and it's going to find this function on this script, and it's going to pass it 1. And in theory, I could have more than one thing in here in my ball script. I could have brick or whoa, that went a lot farther than I expected it to. We could have destructible. I can spell, I swear. So if we if we did this, then anything that would be tagged with destructible would also be dealt damage to. Likewise, if we wanted a multiplier, we could say times damage multi. There we go. We probably want that minimized. And then we could have an integer up here for what our damage multiplier would be. So we could go int damage multi equals 1. There we go. So at the moment it's going to be 1 times 1, but then if, we could, in theory, where we have the set speed and get speed and all that stuff, we can just say public void set multi. And then we're going to have an int value of new multi, and then we can say damage multi equals new multi. And if we wanted to, we could set a min and a max and all that stuff up here and clamp that value if we wanted, but we don't necessarily have to. So what that's going to let us do is say that we got to a certain speed. Like say we got to max speed, we can start dealing more damage to things and we can start blowing things up more. Interestingly enough, that could be a bad thing for the player because dealing more than 1 damage becomes inconsistent, so they might get confused as to why some bricks that look identical take different amounts of hits to destroy. It's also bad mechanically because they're effectively getting less points. They're going to destroy the thing regardless, but if they destroy it in 5 hits, they get 5 points plus the 12, or 4 points plus the 12. But if they destroy it in 2 hits, they get 1 point plus the 12. So they're actually getting less points. It's a bad thing for them it's effectively a bad thing to do well at that point. So we might not want to do that. We might want to instead give them a power-up that lets them break through bricks so that they can enable it. As soon as it becomes their choice, it's a lot better because then they're choosing to forgo the extra points for the destructibility that they gain. Technically, it's also kind of a good thing for them because of the speed increase. They destroy things with less bounces, so the ball is going slower, which is more controllable. It's kind of a... there's a design principle for it, and I forget the name of it, but the idea is you have an object, or you have a power in your game, or an ability in your game, or a mechanic in your game that allows new users to keep the game easy that experienced users can use in controlled situations. That it's strategic for them, but it's for a new user, it's used to mitigate the difficulty. Anyway, that's kind of what that would be. It's kind of a design ranty tangent, but yeah. So anyway, point is, we're feeding the brick 1 damage, and the brick takes that damage, and it decreases its current health. What I should be doing here is minus equals damage, which I'm not doing for some reason. DMG. I was just ignoring that I was feeding it damage. And that will subtract the... actually, we should make this equals... clamp... Or is it mathf.clamp? Oh, go away, damage. Mathf.clamp... And we're going to say current health minus damage, and then the minimum and the maximum is going to be our starting health. So this is actually going to set our current health to whatever our current health minus damage is, but we're going to clamp that at 0 because we don't want it to go negative. That would be a bad thing. Yeah. And I'm printing out a little debug message saying I hit the brick and it has that much health left. That was for me to test that my brick script was working. And then I check to see if the current health is less than or equal to 0. If it is, I print out some debug stuff and I add points to my system, which I'm not going to talk about. Again, I'm going to talk about that next video. And then I destroy this object. If we're not destroyed, then we send message, add points, the hit score. So this is the destruction score, and the next one is the hit score. Again, cover that in the next video to more length, but for now, moving on. At the very end of this, we're going to set the local scale of our viz mesh to 1 minus the... our local scale times 1 minus the viz mesh scale increment. So effectively, this is going to be... What is it? It would be 0.8... 0.885, I think. Is that what it would be? No, it'd be point. Oh, what is it? I'm going to open up my calculator here. 1 minus 0.125 is going to be 0.875. I was close. So this is effectively going to set it to 0.875, so 87.5% of what the local scale of it currently is. So it is a percentage, sort of. Yeah. And then I just do that every time it's hit and doesn't die. Because when it destroys up here on this line. It never actually makes it down to these lines. So this will only ever happen if it is hit and then isn't destroyed in the process. And that is all there is to the brick. So to go over it one more time, it just exists. It doesn't actually do anything frame to frame. But when a ball hits it, it gets damage called on it, which then sets the health to its health minus the damage. And I print out some debug stuff, and I check to see if it should be destroyed. If it should be, then I destroy it. If not, then I just give myself the points for hitting it. If it is destroyed, I give myself the points for destroying it. And then I shrink the mesh down a little bit using this line here. Yeah, that's really everything on this guy. And that, once it's done recompiling, a little spinning wheel down here, I will run it and make sure that my changes that I just made to how I'm setting health actually work, which would be useful. So I'm going to hit this guy, and yep, it behaves exactly the same as before. That's everything. But now, if I grab the ball, where's the ball? There it is. And I set that, oh, I can't send message on something. Hang on. I wish I could. Oh, I was going to test the multiplier, but I won't do that right now. I'll do some trickery between episodes and show you guys that. So the last thing I wanted to talk about was these catchers. The thing that the volume that I have here that catches my ball when it goes out of bounds. The main reason why I have it set up like this is so that well, this has worked in the past for me for cleaning up extraneous objects, like extraneous things that I've spawned that I have fallen off screen or whatever. So like if in theory when I hit one of these, it spawned a rigid body mesh that then fell, so like it shattered the brick, and then I have the pieces like fall off the screen. This catcher volume here would actually catch all of those objects and delete them from my scene, so they're not just floating through space infinitely. That's kind of the intent of it, but also I'm using it as a double purpose thing to catch the ball when it goes out of bounds and return it to my my paddle and reseed it in my paddle, which I know I've talked a little bit about on the paddle side of things, but this is the catcher side of things. So the script itself is pretty simple. It has I need the tag for the ball, I need the tag for the paddle, so those are both strings, and the tag for ball is ball and the tag for paddle is paddle, so that's pretty straightforward. So I have those set to that. It also has a kill mask. You'll notice that it's set to nothing right now because there's nothing in the scene that necessarily will fall off the screen that I need to collect and destroy. But if I set that to, say, default, then anything that is tagged with default that ends up colliding with this thing will end up being destroyed. And if you will indulge me for just a second, I will make a little cube that has a rigid body and a... I'll put it right there. And it's going to have a rigid body on it. And the rigid body is going to obey gravity, so it is going to fall. And when it falls, it is going to be destroyed because the catcher has default in its kill mask, and my little cube here is on layer default. So check it out. When that cube falls, it hits the volume and it destroys. If you want to see a better test of that, I will go over here with it, and I'll raise this guy up a little. Come on, I'm clicking all sorts of stuff. Jeez. So I will hit play now, and you'll see that when it hits that volume, it kills that object. But if I set the cube's layer to, say, UI, even though it's not a UI object. Doesn't really matter. When that cube hits it, it's going to keep on surviving. It's going to keep on falling. So it's effectively like a gate. It is it's preventing certain objects from passing through it, and it handles some special logic for when the ball hits it. And that's really it. So yeah, let's look at the script really quick. And I realize I'm at the 20-minute mark, so I'm going to make this really, really quick, because this is the entire script. This is it. So it has those two strings and a mask, like I was saying. It also has my main object, which is the same system script that I was talking about before. So again, we're going to pass right over that guy, again with the finding the system script. And then it has this on trigger enter, which I know I've talked about in my collision video. But basically the catcher thing here is actually it is a trigger. It's a trigger volume. And the reason why it's a trigger volume is because I don't want things to actually hit it. I just want to know when things pass through it. So when something does pass through it, I see if the object's tag is what we have set for ball tag. And if it is, then I'm going to find a game object with tag. I'm going to find the paddle, and I'm going to send message to the paddle. I'm going to give it the ball right here, the collision object, which I hit, that has the ball tag on it, and I'm going to tell it to seat the ball. And if you remember back to my last video with the paddle controller, seat ball takes a game object, and it parents it to the seat object inside of it, inside of the game object. Inside the prefab is a better word there. So yeah, that's this function is called using the catcher. The catcher sends a message to it and feeds it the ball, and then the paddle seats the ball, disables it, and does everything that it needs to do with the ball from there. I debug a little message to myself, and I am telling my system that I dropped the ball. Great. So that's going to be important in the next video, but this is kind of how I keep track of lives, if that makes sense. Now, if it's not the ball, if it's not tagged with ball, then I'm going to do this little this function here. This is in layer mask, which I will talk about in a second. This basically says that, hey, is my object inside of my kill mask? That's all you need to know for now. And if it is, then I'm going to debug that I caught something and I'm going to kill it. So then I just destroy that game object flat out. So that's pretty simple. The complicated thing is this is in layer mask, because I haven't talked about how to do any of the stuff that I'm doing in here yet. So the long and the short of it is I'm doing some bitwise stuff and some what are they called? Some bitwise comparisons and some bit shift operators. I wrote it down because I never remember the terms for that. So this guy right here is a bit shift operator. And effectively what I'm doing is I'm going to take this layer mask and I'm going to convert it to an integer. And I'm going to read it as if it is an integer, is a better way of saying it. And I'm also going to do the same thing with this thing's layer mask. And I'm going to see if they, through comparisons, line up right, I guess. That's a bad way of saying it. So I'm going to take this integer here, my object layer mask, and I'm going to shift it 1, I believe, for as many as this object layer is. Effectively what I'm doing there is I'm setting it to the integer value of this object layer. So they're going to come out the same. And I have a couple debug log warnings here, and I'm going to show you what all this looks like in logs, hopefully. But using some trickery of like pausing Unity in the middle of an operation happening and stuff like that. You'll see. So this is effectively, this line here is going to set my object layer mask to my object's layer as an integer value. That's basically what it does. And then this if statement here is kind of interesting because normally it's an and, but that's usually over here. So what this says is the really, really easy way for me to say it is this is an and, which is confusing because the other statement is also an and. This is a bitwise and. What this says is if this and this are greater than 0, then we're going to return true. That's basically all it is. So it's similar to saying something like if x equals, oh, I can't make up a fake variable. So if x equals or is greater than 0 and y is greater than 0. It's basically kind of like this, except without the unnecessary and symbol here. But it's also worth noting that bitwise stuff only works with integers, and I think they also work with bools, because booleans are basically integers. They're just a 0 and a 1 integer. So yeah, that's what this is saying. If this and this are both greater than 0, are greater than 0, then return true. So that's probably a really bad explanation. If you know more about bitwise comparisons and bit shift operators, please comment in the comment section, and I will upvote your comment and make sure that it's at the top for everybody to see. You're probably going to be much better at explaining it than I am. I'm very, very new to bitwise comparisons and bit shift operators, but they're kind of handy. But yeah, that's effectively what this stuff does. And if feel free to copy this and use it if you need. It's just an easy way to do a layer comparison without collision, because that's really what layers are for a lot of the time. And this there is a collision check here, but the way that we usually have done in the past, the way that we have done collision layer tests in the past is by through like a raycast or something, right? Like you do physics.raycast and you feed it your layer mask, but we're not doing a raycast here. We're not doing any kind of a physics dot operation. We're just catching the object in a collision enter, and then we're seeing if it's in a kill mask. And I don't know how else to do that other than using a function like this. So yeah, but that's basically what our catcher does. It's kind of a multi-purpose thing. It gives us points, it seats our ball, and it also cleans up our scene for when we need it to. Well, it doesn't give us points necessarily. It actually takes a life away, but whatever. It interacts with our system. It interacts with the ball. It interacts with other objects in the scene. And I think this is really, really handy for how small of a script it is. So if you're ever making a game like this, or what I've used something similar to this in is a shmup. I made a little like top-down space shooter game that you can find on my website if you can find my website. But I used something similar to this to catch enemy objects, like enemy ships, as they flew down the screen and they went off screen. They had to go somewhere. So I just put a big volume at the end that kind of caught all of the environmental objects and things like that flew off screen, and got rid of those and like cleaned them up and like told them how to shut down and stuff like that. So it was a much longer script than this, because I had individual cases for the different classes and things that were attached to things. Like enemy ships were handled differently than enemy projectiles, and enemy ships and projectiles were handled differently than environmental things that I had floating down the screen. So yeah, stuff like this is fairly common, I would say, in games. And like even in AAA games, I can think of a lot of places that I would use something like this for, like the end of a cliff. You would want stuff that falls off of that cliff to probably have some sort of volume to catch objects and reset them somewhere, like your player. If a player jumps off of a cliff, you don't want them falling infinitely. You want them to hit a volume and then like fade to black and then replace them somewhere else, you know? It's effectively the same thing. It's just this time it's a ball. So yeah, in the next video, I'm going to be talking about my main object here and what all this stuff does, and how I interact with the score. It might be a two-parter. I might talk about the systems, and then I might talk about how I'm doing the scoring stuff, because I do have another script as well called the score up display that has a little prefab associated with it. That's a little thing that like appears and shows you your point value and then goes away. Really, really handy for a lot of different games, and yeah. So I'm going to be talking about that a bit. I'll open it up here for you to see what I am talking about. With that is also going to come this other script that I have here called Game Over Screen, and kind of how I handled game over and points, and how everything is kind of interconnected with each other, like the different parts are moving as a system. So yeah, hopefully that'll be interesting, and that'll be really useful, I hope. If anything in here was confusing at all, or other than this little like is in layer mask function, if that was incorrect, let me know. But if anything was confusing, comment, ask questions. I'll provide links if I can't explain it myself or show you code myself. Yeah. Thanks for watching, and I guess that's it. Bye-bye.